Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss expression for most probable speed, average speed and root mean square speed by using Maxwell's Boltzmann distribution law of velocities. Let's begin. First we discuss about most probable speed. How to calculate the most probable speed? First we know the number of molecules of an ideal gas having the speed v and v plus dv, that is n v dv with the number of molecules in that of speed range from Maxwell's Boltzmann distribution law of velocities, that is 4 pi n m divided by 2 pi kt to the power 3 by 2 v square e to the power minus mv square divided by 2 kt dv. That is the number of molecules of an ideal gas in that of speed range. Hence, the probability of that of molecules in that of speed range means the probability of finding of particles. Hence, the probability that molecules possessed the speed between v and v plus dv, the probability of that molecules that given by p v dv with the probability, that is n v dv divided by n v dv, that is the number of molecules in that of speed range to the total number of molecules, is known as the probability of that molecule in that of speed range. So, that is given as, so we write pv dv is equal to nv dv divided by n. So, dividing n cancel out, so it will be 4 pi m divided by 2 pi kt to the power 3 by 2 v square e to the power minus mv square divided by 2 kt dv. Only pv will be dv cancel out, it is 4 pi m divided by 2 pi kt to the power 3 by 2 v square e to the power minus mv square divided by 2 kt. What exactly that equation gives? From this equation gives the probability that molecules will passes the speed v here in that of speed range, but that equation, this equation gives the probability that molecules will passes the speed v, the speed v. So PV is equal to C V square e to the power minus mv square divided by 2 kt, where we take C is equal to that quantity, that is 4 pi m divided by 2 pi kt. These terms are constants, these are constants at a given temperature T. Now differentiating that equation with respect to V, what we have? Differentiating with respect to V, we get, that is del P by del V, C as constant to outside. So that integration by using the product of integration, we get 2V e to the power minus mv square divided by 2 kt plus, next that integration, it will be integration of this, that as constant, then integration of that, this will be constant. So v square and e to the power minus mv square divided by 2m kt into minus 2mv divided by 2 kt is equal to C e to the power minus mv square divided by 2 kt minus mvq divided by kt plus 2v. It is del PV divided by del V. But we have to calculate the most probable speed. This is the probability of that of molecule, and we differentiate how the probability change with respect to V. So at most probable speed, what happens? At most probable speed, at most probable speed, that is the velocity is written as V most probable, and del PV by del V is equal to 0 at most probable speed condition. Therefore that term will be 0. So we write C e to the power minus mv square divided by 2 kt minus, okay, that is mv of most probable speed. So 2, that is 2 v of most probable minus m vq of most probable divided by kt. In place of v we substitute, that is most probable, equal to 0. That term will be 0. So we have that bracket term 2 velocity of most probable minus m v most probable q divided by kt is equal to 0. V most probable taking as common, that is 2 minus m v most probable square divided by kt is equal to 0, or 2 divided by m most probable square divided by kt is equal to 0, or m v most probable square divided by kt is equal to 2 here, to that side it will be positive. Next mv most probable, or v most probable, that is 2kt divided by m under root. That is the expression for most probable velocities by using Maxwell-Boltzmann distribution law of velocities. That is v most probable is equal to under root of 2kt divided by m. Next expression, this is the expression for most probable speed. Now the average speed. Second one, average speed. Average speed, that is v average. The average speed of the gas molecule is defined as average speed of the gas molecule is given as, or we defined that is v average is equal to integration from 0 to infinity v nv dv divided by integration from 0 to infinity nv dv. Nv dv, that is the total number of molecules, and nv dv, as we discussed, that is the number of molecules in that of velocity range v to v plus dv. So here v average is equal to integration of 0 to infinity n, that is v into nv dv divided by that integral value will be n, that is integration from 0 to infinity nv dv is equal to n, that is the total number of molecules. Now putting the value of nv dv here is equal to, that is integration from 0 to infinity, that is 4 pi n m divided by 2 pi kt to the power 3 by 2 vq e to the power minus mv square divided by 2 kt dv. Here v multiplied with that of v square, the term will be, that is v square when multiplied by v, the exact term will be vq. Here that term will be vq divided by n. To solve that integration, the constant term to that of outside, that is 4 pi n m divided by 2 pi kt to the power 3 by 2 divided by n, integration from 0 to infinity vq e to the power minus mv square divided by 2 kt dv is equal to 4 pi 1n cancel out here, that is m divided by 2 pi kt to the power 3 by 2 integration from 0 to infinity vq to e to the power minus mv square divided by 2 kt dv. Here we use the standard integral. From standard integral, integration from 0 to infinity of x cube e to the power minus alpha x square dx is equal to 1 by 2 a square. So putting that standard expression to that of particular integral, we have, that is here 2 pi cancel out, so it will be root 2 pi m by pi kt to the power 3 by 2 integration, sorry, that integral value is 4 k square t square divided by 2 m square. Then simplifying it, total simplification results 8 kt divided by m pi under root. This is the value of V average. V average is equal to under root of 8 kt divided by m pi. We define the V average, just integrate, and finally we get the value of V average. Last one, that is root mean square velocity. Third one, root mean square speed, that is VRMS, root mean square speed, root mean square velocity. Again we define for that of root mean square speed, root mean square speed of gas molecules is defined as V RMS, root mean square, is equal to integration from 0 to infinity V square NV dV divided by integration from 0 to infinity NV dV. Here NV dV is the number of gas molecules in that of velocity range V to V plus dV, and the value of NV dV integration of 0 to infinity, that is the total number of molecules N. So the term, that is 0 to infinity V square NV dV divided by N as 0 to infinity NV dV is equal to N, total number of gas molecules. Here we put the values of NV dV, that is integration from 0 to infinity 4 pi n m by 2 pi kt to the power 3 by 2 v to the power 4th e to the power minus mv square divided by 2 kt dv whole divided by n. The constant to that of outside, that is 4 pi n m by 2 pi kt to the power 3 by 2 divided by n, integration from 0 to infinity v to the power 4th e to the power minus mv square divided by 2 kt dv is equal to 1n cancel out, that is 4 pi m by 2 pi kt to the power 3 by 2 integration from 0 to infinity v to the power 4th e to the power minus mv square by 2 kt dv. Again we use a standard integral here. So using the standard integral. Here we use from standard integral, that is integration from 0 to infinity x to the power 4th e to the power minus alpha x square dx is equal to 3 by 8a square under root of pi by a. That standard integral is used here. So we have v RMS square. Okay, the expressions as we write, this is the square. Okay, v RMS square is equal to 4 pi m by 2 pi kt to the power 3 by 2 into 3 divided by 8 into m by 2 kt square pi divided by m by 2 kt under root. Now simplifying that one, that is 3 by 2 m by 2 kt to the power 3 by 2 2 kt by m to the power square 2 kt by m under root. It will be 3 by 2 to 1 by m 2 kt, that is 3 kt divided by m. So finally v RMS is equal to under root of 3 kt by m. This is the expression for root mean square velocity. This is the root mean square velocity expression, that is the v average expression, average speed, and this is the most probable speed expression. Now we take a relation in between these three speeds, relationship in between these three speeds. How we have to relate? We know v RMS is equal to 3 kt by m square root, means root 3 kt by m square root. The value of root 3 1.732 kt by m square root. Next v average, that is 8 kt by m pi square root. So 8 by pi kt by m square root, 8 value of pi, that is 22 divided by 7, so 7 by 22 under root kt by m. Simplifying that one, we get 1.59 kt by m, and v most probable is equal to 2 kt by m. So 2 root 2 kt by m square root, value of root 2 1.44, that is kt by m. Here kt by m under root is common in that three cases. Therefore v RMS is to v average is to v most probable. The ratios of these three, it is 1.732 kt by m under root is to 1.59 kt by m under root is to 1.44 kt by m under root, which is equal to 1.732 is to 1.59 is to 1.44. Now dividing 1.732 in these three, 1.732 is divided all these terms, 1.732, 1.59, 1.732, that is 1 is to 0.92 is to 0.81. This is the V RMS, V average and V most probable, how these three are related. Means V RMS, V average 0.92 times and V RMS to that of most probable 0.81 times. So with the help of this video lecture, we understand the expressions for most probable speed, average speed, and finally root mean square speed. And their relationship, how these three are related, by using the concept of Maxwell-Boltzmann distribution of velocities. So with this useful and informative notes, let me wind up this session. Thank you.